Welcome to this lesson on the parts of a circle. Notice that we have this drawing here that's got a lot going on. No worries, we will be reviewing and looking at the different parts of this circle. So let's go ahead and get started. Center is what you might already imagine. It's the center of a circle. So for the big circle, the center is C. For the little circle, the center is G. Next thing is a chord. Chord is any line that starts at the circumference of a circle and runs to the other end of a circle, like that. Next thing is diameter. A diameter is a type of a chord, because again, remember, chord runs from one end to the other end of a circle. So a diameter is the line that starts at one point through the center to the other end of that circle. So AD would be an example of diameter. Next thing is radius. Radius is half of diameter. So anything from the center of a circle to a point on the circle, for example, CH, that would be a radius. AC is another example of radius. CD is another example of radius. On the smallest circle, FG is a radius, and of course GE is also a radius. Next thing on this list is the point of tangency. The point of tangency is the point where a line touches the circle. The line has to be on the outside. It's an external line. So a point of tangency could be focusing on this line right here. D is a point of tangency because an external line is touching a circle only at one point, and focusing on this other circle. E would be a point of tangency because it's touching the small circle externally at one point. So E for the big circle, or rather D for the big circle, and E for the small circle. The next we have common external tangent. Common external tangent is a tangent that touches two circles. They share a tangent. So you notice again, this tangent here is touching both the big circle and the small circle. And we name circles based on their centers. So when I say circle C, I'm referring to the big circle. And when I say circle G, I'm referring to the small one. Circles are referred to by their centers. So a common external tangent between circle C and circle G is this tangent. So tangent DE. A common internal tangent is a tangent that again touches both circles, this time internally. This line right here is a common internal tangent, and it happens to be line HF. A secant is any line that cuts through a circle. So if you have a line that's cutting through a circle, you can call it a secant. An example of that would be line AB. It cuts through a circle. Don't confuse secants with chords. Chords do not cut through. They start at a point on a circle and end inside. They never cut through. A couple of other things that you have to be familiar with when it comes to circles and tangents and radii. Notice that every time a tangent, like for example this line right here, comes into contact with a radius or a diameter, they always intersect at a 90-degree angle. Notice again, for this tangent right here, when it comes into contact with a radius, 90 degrees. It happens here again for the small circle. Tangent coming into contact with the radius, 90 degrees. So that's an important fact. When a tangent intersects a radius or a diameter, they intersect at a 90-degree angle. Right there, right there, right there, and right there. Another fact is as follows. Anytime a diameter is part of a triangle in a circle, that triangle ends up being 90 degrees. So I'm going to use the diameter AD to create a triangle in here, like so. Because the diameter is part of that triangle that I just drew, this angle has to be 90 degrees. Another very important fact to keep in mind. Welcome to this lesson on arcs and angles in a circle. Once again, remember that we name circles by their center. This time I haven't assigned a center to this circle, but we can go ahead and do that. Let's put a center right there, and we'll call this C. So this is circle C. If I drew a line from the center to a point on that circle, we call that a radius. And if I do that again from the center again to a point on that circle, that's another radius. Let's just say the point of contact here is A, and let's say the point of contact here is B. What we've done is created AB, which is what is called an arc. So an arc is a part of a circumference. If you found the distance around a circle, that's called circumference. So if you just get a part of that, that's known as an arc. Moreover, now that we've drawn that arc, we see that there's another arc that emerged on the other side. The smaller arc, which is AB, can be referred to as the minor arc because it's just the smaller of the two. So arc AB would be the minor arc. On the other hand, the bigger arc, if we were going to name it, it would also be AB, and you might see that that creates a little bit of a problem. If I referred to the bigger arc as AB and the minor arc as AB, then you would go, well, which one are you referring to? So anytime you have two arcs, name the major one using 3 letters. So that means we have to introduce another letter here. Why don't we just use D? That means the major arc would not just be named AB, we would have to name it ADB, arc ADB. So that's how we have major and minor arcs. Moreover, there are angles involved when you have arcs. So if you measure the degrees of a circle from one point all the way around, you would get 360 degrees. So anytime you're looking at an arc, for example, the minor arc AB, and you assign it a degree value, let's just pretend that this is 60 degrees, we can find out that the major arc is basically 360 minus that 60, which would make it 300 degrees. Moreover, there's a relationship between the arc, again looking at arc AB, and the angle that gives you that arc. The correct terminology is the angle that intercepts that arc. Notice that this angle, this one right here, starts at the center, so we call that a central angle because it starts off at the center. And when you have a central angle and an arc given, those degree measures are equal. So if you were going to change these angle values and maybe call this 50 degrees, guess what? This angle would also have to be 50 degrees. Sometimes the angle that's intercepting an arc doesn't always start from the central angle. It could start from all the way back. So if I drew a line all the way back to here and another one all the way back to here intercepting that same arc, notice that that angle, this angle here, is intercepting that arc. Let me redraw that. This line right here and this line right here, those intercept arc AB. Since it's not a central angle, the relationship is different. They're not equal anymore. That angle is always half of the arc degree. So because arc AB is 50 degrees, angle that intercepts it is 25 degrees.